Hi guys, welcome to the fifth weekly, 15th weekly webinar of WIDS Mumbai weekly webinar series. Today is our finale of the webinar series, and so a little introduction about WIDS. So WIDS is a global Stanford initiative. It has been conducted so far in 150 plus cities, 60 countries, and it has reached 100,000 participants worldwide. So WIDS is an abbreviation for Women in Data Science. It was started to support women data scientists in the field of technology. So the WIDS Mumbai edition was started first in 2018. It was conducted at VGTI College. The major aim of WIDS is to inspire women to join the field of data science and to give them the resources so that they can equip themselves in this field, to educate them, as well as to support the women who are already in this amazing field of data science. Women in field of data science, data analytics, statistics, math, machine learning, AI, it's all a part of our small WIDS committee. So here are our ambassadors for WIDS Mumbai, Julian Joseph, Kartika Kamath, and Khushbu Peswani. We have also formed a small committee of data science enthusiasts who are supporting each other, sharing links with each other, and trying to inspire so that each one can get on and do what they want to do in this field of data science. So the WIDS Mumbai conferences have been conducted for the past 3 years. It started in 2018, like I mentioned before, where we had 8 phenomenal speakers in the field of data science, women speakers. The next conference was held in 2019 at DJ Sangvi College, where we had 9 women speakers. And this year, due to the pandemic, we are hosting online webinar series. We have been doing it for 15 weeks. And according to a poll which we received, we also decided to do code along workshops so that we can get more hands-on experience in these data science. So here we have all our series which were conducted. It started from the month of May, and now it has been July, and we are like wrapping up our webinar series. We have covered various topics, as you can see over here: how you can transition to data science, blockchain and data science, AI and medical imaging. We have a vast series covering lots of topics. So you can take a look at our channel to get more information and watch our videos. And of course, like, share, and subscribe. And you can follow us on our various handles. We are on YouTube, Instagram, Spotify, Medium, Facebook, Twitter. So give us a follow. So today we have a speaker, very important speaker with us, and Saumya. Saumya is a software engineer at Cisco. She's passionate about diverse, secure, private, and ethical AI. When she is not working or keeping abreast with the latest technologies, she volunteers her time to various initiatives to increase participation of underprivileged and underrepresented sections of the society. Now she will be talking on responsible AI. It's really great, Saumya, to hear what you're doing and how you're helping the underprivileged people. Hi, Saumya.
Hi, Aksa.
Okay, so I'll stop sharing my screen now and over to you, Saumya.
Thanks, Aksa.
You want to start sharing your screen?
Yeah. Is it visible?
Yes, it is.
Okay. Hi, everyone. Today, I want to introduce you to responsible AI and why we need it, what it means, and for every single data scientist or analyst in out there, why you need to be careful about what it is that you develop. So, why do we need responsible AI? As you know, AI has seeped into every single application in our life, and every time we open our phone, we are basically there are artificial intelligence systems that we are interacting with. And with the vast deployment of these AI systems, there are novel threats that have emerged. These AI systems are subject to biased outcomes. And how do we ensure that in sensitive use cases, we are able to provide uh, accountability and trust in these AI systems? So, today we're going to be talking about these 5 principles of responsible AI, which is governance and accountability, ethics and regulations, interpretability and explainability, bias and fairness, and robustness and security. Let's start with governance and accountability. If you look at the image on the right side, what it shows is the entire life cycle for an artificial intelligence system. What accountability essentially means is that those who design and deploy AI systems are accountable for the way that they function. So, at every single step of this particular life cycle, it's necessary to plan risks and controls. It's also necessary to have logging and audit trails for continuance of compliance. When designing any artificial intelligence system, it's necessary to think about how they were designed, for what purpose, where the data came from, why it was chosen, and how it was trained, tested, and corrected. So, how do we ensure that accountability and governance is in play, especially in larger deployments of AI systems? One of the most essential ways is by maintaining data sheets for data sets. And what this does is it records every single key information related to a data set: the composition, what process was used in collection, the recommended use cases, who is maintaining this data set, what distribution it allows, and more importantly, the legal and ethical considerations. If you look on the right, it has a sample legal and ethical considerations of a data sheet for a particular data set. Why this is really important is because there are data sets that are shared within an organization or with people outside an organization. And the first step to understanding and maintaining accountability for a particular AI system is to understand where your data has actually come from, where it can be used, how it was collected, how it was pre processed, and then decide how it can be used. Another important tool that is good to have is a model card. This is similar to a data sheet for a data set, except it has all the information related to a particular model that will be used. It outlines the model details, the intended use, the factors, metrics, quantitative analysis, ethical consideration, and also the caveats and recommendations. Similar to how software engineering applications have DevOps pipelines, machine learning applications also need to have ML ops. With the large scale of AI deployments in today's world, it's necessary to manage full life cycle of ML ops. What this helps with is scaling ML applications to ensure response times, and also to have systems in place for troubleshooting in case of detection of any bias in the system or security or privacy vulnerabilities. Having a end-to-end ML ops pipeline will ensure that you can have continuous and seamless integration and deployment. It also helps to maintain your ML health. And by ML health, I mean uh, monitor drifts in the and deviations in the model behavior, and also the way your users interact with your particular model. It also allows for model governance, in which it maintains logging and audit trails. So what do you need for ensuring that your model is has accountability? Ensure that you have internal review boards, your employees are trained, and humans are kept in the loop. Also have a clear system of accountability and governance for that particular solution. Let's now talk about ethics and regulation. One such solution was Clearview AI. What it essentially was is a facial recognition app. On uploading a photo of a particular individual, it retrieved matching photos of that person from the internet with links. So it basically got a person's address, their IP address, their name, where they lived, what they did, and whom they knew. By scraping billions of photos of the internet, and 600 law enforcement agencies started using Clearview AI last year. Why is this particular solution a problem? Let's think about it from another perspective. What if you were somebody in a witness protection program? What if you were somebody who was hiding from your abuser, or a person that you were afraid of? This particular AI system made you vulnerable. Another solution that was deployed was this program called Compass, and it was used for case management and decision support in US courts. It had three different scales of whether or not an individual was likely to recommit a crime, a violent crime. And based on this, the suggestions provided by this particular AI solution, the courts decided the punishments for individuals, whether it would be severe or not. It was found out that only 20% of the people predicted to commit violent crimes actually went on to do so. And the system was biased towards particular sections of the society. But why does this solution sound so familiar? It's because we would have already heard about it in the Minority Report, where a pre crime unit was set up to predict crimes before they happened. And well, we all know how that turned out. So, some of the nations involved in setting regular regulations around artificial intelligence are shown here with their initiatives for AI regularization. So, before any particular AI system is being developed, it is essential to evaluate the use of your solutions, especially when they are going to be used in sensitive cases. And these 3 points account for what sensitive cases make. Is your AI system going to deny consequential services like finance, healthcare, For example, something simple as having an AI system predict whether or not a person is eligible to repay their loan, whether the person would repay their loan or not. It sounds simple enough, right? But what if that system was biased towards this particular section of the society? And because of that, it did not allow it predicted that these particular people would not repay their loan, hence denying them services that were essential to them. Something that like Clearview AI would definitely cause risk of harm, and something like Compass is definitely an infringement on human rights. One way to ensure that your artificial intelligence and machine learning software is not used in specific harmful applications is by having real licensing for AI and ML software. And what these licenses essentially do is say that these particular software cannot be used for applications like that you define, for example, surveillance and crime prediction uses, while it allows other applications to use your software. Let's talk about interpretability and explainability. Why do we need transparency? Why people need to understand how decisions are made? For one, it does help the stakeholders identify performance issues, identify if there are any safety and privacy concerns, if biases are being present in your AI system, if particular races, genders, or sections of the society are being excluded, if there are some unintended outcomes of the solution. Why interpretability is needed to a particular data scientist or data engineer is it helps in model debugging. Why did a model make a particular prediction or a mistake? Are there any fairness issues? Does it discriminate against particular genders or races? To facilitate trust between humans and AI, to ensure that humans trust the systems that they use, to ensure that the models satisfy legal requirements, and to ensure the use of such applications in high risk areas like healthcare, financial, and judicial applications, where it is very essential to understand and be able to trust the judgment or a classification made by a particular system. So let's look at the performance versus interpretability of certain models. When I say performance, I mean performance in a very complex application with thousands of features. In that particular use case, deep learning model would probably perform better. But the actual understanding of how a particular decision was reached is much less in deep learning models as compared to something like decision trees or linear models. So, what exactly do we mean by explainability? One way that we would explain this is that I want to understand on a whole what my model considers important, what features it attaches importance to. That would come under global explainability. For local explainability, what if I wanted to understand how one particular prediction was made? can have white box and black box models. White box models essentially is models that have a high level of visibility. For example, linear or logistical models and decision trees, whereas black box models would be models like neural networks and deep neural networks. One way of local explainability is actually having visualization techniques like correlation graphs or principal component analysis, or also surrogate models, one of the most popular being line. Let's look at this more closely by looking at some of the toolkits that are available across different platforms and how they tackle these particular decisions. So let's look at what Interpret ML by Microsoft Research Group does. If you look at the leftmost column, it provides global explainability, which basically shows how much importance this model attaches to every particular feature. In the second column, you would see visualizations of basically the first graph, for example, of how the score varies across different ages. And in the third column, you would see local explainability of how one particular decision, for example, one particular data sample, which was predicted as zero and the actual value was zero, and what factors contributed towards the prediction of that particular value. Another toolkit for explainability is AIX or AI Explainability 360 by IBM. And they have this really intuitive graph that is there here that tells you what exactly you have to use for each particular situation that you might want to explain. Do you want a local or a global explanation? Do you want to explain your data or your model? And do you want a feature based explanation or case based reasoning? And another tool is What If by Google, which basically has understanding of black box classifications or white box models that allows you to explore data directly from a CSV file. A distinguishing feature of this is basically optimizations for fairness strategies like demographic parity or equal opportunity. So let's talk more about bias and fairness. Recently, it has come to notice that a lot of facial recognition systems do not work as well for people of color, and it misidentified them at rates of 5 to 10 times higher. One of the most famous examples was the solution called Face Depixelizer, in which, given a pixelated image, it gave you a clear, high definition image of the person. This was made using style generative adversarial networks, but we found out that it was not particularly accurate when it came to processing people of color. And it ended up giving faces that are surprisingly Caucasian. One of the reasons why this would happen is because of the training data that was used. If the training data is not diverse enough and does not have all particular uh, people that you would like to represent, the model becomes biased towards the people that you do have in the training data set. One way to go about this is IBM Research published a data set called Diversity in Faces. which has 1 million human facial images of various different ethnicities and backgrounds. Also, it has 10 facial coding methods, including craniofacial, facial ratios, visual attributes, pose, and resolution. One thing that we generally miss out when thinking about diversity is also thinking about inclusiveness. Does your particular system or solution or software include people with disabilities? Do you have a speech to text recognizer that works for people who have speech impediments? So, for inclusiveness, we need to have people with disabilities test your system. We need to consider what are the commonly used accessibility standards and also educate system developers and comply with laws regarding accessibility and inclusiveness. Some of the inclusive design principles given by Microsoft is to recognize exclusion, solve for one and extend to many, and learn from diversity. So, what are the 5 basic biases that you need to ensure is not present in your solution? So, the first is data set bias. Does your data set have every single person you intend to cater to? And what is the actual percentage of these people in your data set? Does your particular solution have associations bias that reinforce stereotypes? Does it associate a woman with cooking or a man with wrestling or cars? Is your solution likely to prefer decisions that would be taken by a human being, or does it prefer automated decisions? Is your solution immune to interaction bias? For example, there was one AI bot deployed on Twitter that was allowed to interact and learn from human beings. And what happened is because of the large amount of negative interactions that it had, it began to have racist and anti Semitic uh, interactions with other people. So, when you allow interactions with your users, are you protecting your model against their biases and their negative sentiments? And the last one is confirmation bias. Are you ensuring that your system is ready to adapt to the changing opinions of your users? Also, can it make unbiased and fair predictions? So, how do you really ensure fairness? To ensure fairness, you have to ensure that the same recommendations are made to everyone with similar symptoms, financial circumstances, or professional qualifications. An important thing is to always have human in the loop for decisions regarding sensitive use cases. Use training datasets that reflect the diversity of society and design AI models that allow them to learn and adapt over time. We can also leverage tools, methodologies, techniques, and other resources that help detect and mitigate biases. Now let's talk about robustness and security. So why are we concerned about privacy and security? For one, we know that AI systems don't really have the ability to discern between malicious inputs and benign data. A lot of data is derived from uncurated and unmoderated public data sets. Too much trust is placed on the output of decision making processes. And there are new emerging threats like data poisoning, model hacking, and other threats to machine learning ecosystems. Let's talk about adversarial attacks. Adversarial attacks would cause a panda that was predicted with 57.7% confidence, with a small amount of adversarial noise, to be predicted as a given with 99.3% confidence. What these attacks entail is basically modifying a query to get a desired response from a production deployed model. They can also be similar to denial of service attacks, where some targeted words are used in a way that the system will ban them, denying a particular service to a legitimate user. One way to protect your systems against this is to ensure adversarial training and regularization. Let's talk about this tool called Clever Hands. What it does is it benchmarks ML systems' vulnerability to adversarial examples. It does this using many ways of white box and black box evaluations. Let's talk about one particular black box evaluation, which is called a transferability attack. In this case, what it does is it queries the remote ML system for labels on inputs of its choice. It then trains a local substitute with those labels. Based on the inputs and the sensitivity to those output variables, it then uses that local substitute to craft adversarial examples, which are misclassified by the remote ML system because of transferability. Another emerging threat is model attacks. In these attacks, what the attacker aims to do is find out private features that were used in ML models. For example, if there's a model that returns class probabilities, an attacker crafts queries to determine unknown variables in that model. If there is a decision taken by a decision tree or a similar model, an attacker exploits APIs to extract what decisions are being used. A transferability attack is one similar to the one we saw in the previous slide. In some of these attacks, researchers were able to predict a patient's main surgery based on their attributes or recover an image based on the person's name and access to a facial recognition system. So, how do we deal with these model attacks? The first and most important thing is to ensure that there is a strong access control to these models. The next is to rate limit queries allowed by a model. Since any of these attacks would require multiple large amount of queries to be made to the model. We should have input validation on all proposed queries and ensure that only the minimum amount of information is returned. Two other solutions are homomorphic encryption and differential privacy. So, Homomorphic encryption essentially allows you to perform analysis on encrypted data. If you look at the image on the right, it's of an example of TensorFlow underscore encrypted module. And if you look closely at the way it is used, it is very similar to the look and feel of TensorFlow. Another thing that I wanted to talk about is differential privacy. Differential privacy operates on the assumption that a query should be same with or without any one particular individual's data. What that essentially means is that a particular data curator or a data holder guarantees that any individual allowing their information to be used as part of a data set does not will not be affected by any in any way. But one thing to note is that differential privacy actually involves insertion of noise. And for that reason, it is only works well with large data sets and for statistical data where statistical inferences are being made. One of the ways in which researchers can leverage this differential privacy to share data sets that may contain private information is by using this tool developed by Harvard researchers called Private Data Sharing Interface, which allows you to upload private data to a secure archive, decide which statistics to release, and define what are the privacy preserving versions that you would like to have. Since differential privacy allows you to basically make the trade off between privacy and accuracy, you can define how much of privacy preserving you would like to have. It then allows exploration through a curator interface for any other person to access this data, but while ensuring that all the people present in that data set are protected. Another solution that I would like to talk about is federated learning. Federated learning is present in each of our cell phones. And what it essentially does is uh, a device downloads the model, then it locally is trained on that particular device. It summarizes the trainings that it has done on the device, and all of these devices send small summarized updates to the central cloud-based model. After averaging all the user updates, an averaged model is sent back to each of these devices. So how do you ensure privacy and security? First thing is to ensure that you comply with any relevant data protection laws like GDPR and California Protection Act. Design AI system to maintain integrity of personal data. Have protections in place from bad actors. Design AI system with appropriate controls. Ensure that anonymity is maintained at every level and conduct security and privacy reviews. So one thing I'd like to leave you to think about is if you've heard recently, there was a tool called Genderify released. And what it did was find out if a particular name, username, or email was male or female. And these are some of the results that it gave. So while you are making your AI system and you all are the startups and the engineers of tomorrow and today, ensure that you're not preoccupied with whether or not you can, so much so that you don't stop to think of whether you should. I would like to especially thank Mushrin, who's a deep learning engineer at Intel, who I reached out to for reviewing and comments on the content that I've presented. Uh, and Saumya, please, I would love to talk to all of you all about AI, machine learning, engineering, or anything in general. So you can connect with me on these platforms. And any questions?
Hi, Soumya. So we have questions. How did you start your journey in data science? Is it too late for anyone from software engineering area to start with data science?
Um, so I mean, it's completely dependent on how you want to. How, what area do you want to work in data science, or is it something that you do in your interests or in your free time? Is that something you want to do? Also, it depends on how committed you are towards data science and data science solutions. A good place to start is to actually interact with people who are doing crowdsourced data science, for example, to solve some challenges in the that some real life challenges. There are a couple of initiatives where people are working towards solving problems that are present in the world. So I think that's a good place to start. They do encourage beginners, also learning from different places, and it's never too late to learn something new, explore something new.
Right. Okay. So if anyone has any questions, you all can post it in the chat section, and Soumya can answer them. We'll just wait for a few minutes to see if there are any questions. Okay. Looks like uh, we don't have any more questions. So thanks, Soumya, so much for sharing on how we can reduce bias or eliminate bias from our AI systems. It is really important, especially in such time where there's lots of discrimination happening and maybe some kind of unconscious bias which creeps up into our systems as well. So yeah, thanks for sharing some insights about that with us.
um Thanks, Aksa. I also would like to thank everybody here for being patient and listening to me. And if there were a lot of things that you didn't understand or weren't able to follow, don't worry. I just wanted to introduce everybody to some of these tools and concepts that are not very often thought about, but are becoming more and more important in today's world. And I had a an article with the links to most of the things that I've referenced for this talk. So,
Yeah, we'll add it in the description section.
okay.
So we have another question from Kartika. Uh, love the content. Thanks for the session. At what stage of a project should we evaluate all the criteria for developing a responsible AI?
And this is definitely comes during the initial planning stage itself, where you should be thinking first about whether your solution is actually ethical in the first place, and then from there, continuing to follow all the different five principles of responsible AI.
Okay, thanks, Soumya. Okay, so with that, I'd like to wrap up the session. This was the last session of the weekly webinar series. So stay tuned for next year's conference, and we have started a podcast series, Data Science Saga podcast, where we are interviewing women in the field of data science and chatting up, and then about the experience in this field and lots to learn. So yeah, do check out our podcast. It is there. The link is there in the description below. We are on Spotify, and also give us a follow on all our social media handles. And stay tuned for the next year's conference. Bye, guys. Thank you. Thanks, Soumya.